Hello everyone, my name is Jacob Magan, and today I'm going to be showing a brief tutorial on how to upload Airfoil coordinates into the program ANSYS Fluent, which is just a CFD program that is commonly used in the universities. So without further ado, we'll jump right into it. So first and foremost, you're going to want to go to the website airfoiltools.com, common website just to obtain all the coordinate files for basically all the airfoils. You can either go to the list of airfoils here and search for it, or you can just go to the the airfoil search button if you have a specific one in mind. For example, I'm just going to be quickly choosing a supercritical airfoil here, so I'll open that up really quick. Here you'll see that there is a DAT file, and this is going to contain all the coordinates that you need. So what you'll do is just copy and paste all these. Oops, I think I copied this a little too much there. This. Perfect. And you will copy and paste that specifically into Excel. Cool. So you'll see here that it is uploaded into one specific file, and we need to actually separate these to make them into two columns. So what we can do is click the whole first column that it is uploaded into, go to data, text to columns, limited, next, click space, next, and finish. And you can just move this coordinate over. So it's there, and delete that. Actually, we're going to keep this column in for a second, and I'll show you why this is. So to upload coordinates into ANSYS, it has a very specific format. So the first column is going to just be all ones. I'm not sure the exact reasoning behind this. I forget it off the top of my head. I just know that's the standard format that needs to be in. So quickly we'll put this down. This all at the bottom. A lot of coordinates in this file. Perfect. Make sure that your coordinates are not, they don't have like a gap like this. So we'll just delete this line. And also, I don't believe this will affect it just for the method we're doing, but for the purpose of consistency with other videos, what I would recommend is trying to order your coordinates in a way where there's not going to be like any discontinuities. Like it's basically would be almost like it's a smooth curve. So for example, you'll see here, this is the leading edge 0, 0, XY coordinates, and it goes all the way down to the trailing edge, and this is all the upper surface, and all of a sudden it jumps back to the leading edge. So we want to make this smooth. So we can do that actually just by quickly inverting these top coordinates. So we'll just create a sequential number all the way down to this point where we want to invert. We'll highlight our area here, go to home, sort and filter, largest to smallest. And that will reorganize them. You can delete this column now. And you can delete this excess column or this excess point on the leading edge. Again, all airfoil coordinates are going to be a little different, so this might be different on a case-by-case basis. So once you do that, you have your ones here, you formatted this, you can then add a sequential. I don't know why it's a different font here. What is this, Calibri? We're just gonna, for consistency, just change this to Calibri really quick. Interesting. I'm not sure why it's doing that. It's kind of odd. What is this? 11. I'm just gonna delete this column. It's another one. I don't know. I got the OCD in that regard. I gotta make sure everything's consistent. Anyways, you can order these files sequentially, and I think you can just actually double click that. Yeah, and it'll go all the way down. Perfect. So here you'll have your ones, your sequential numbers, and then your x coordinates, your y coordinates, and your z coordinates. And because we're just trying to make this three-dimensional figure, you can just click zeros and end up all the way down to the bottom. Well. So one thing to note is that unlike SolidWorks, which reads this in millimeters, I believe ANSYS actually reads this in meters. So this would be 1 meter, 0.99 meters. This would be, that be 0.0033 meters, and vice versa. So if you need to change your chord length for some reason, you have a very specific chord length you're looking at, what I would recommend doing is just add some type of scaling factor here. Maybe 3 if you want to make a 3 meter chord length, or if you want to cut them in half at 0.5, and basically just remake your coordinates and just change your XY coordinates based on this scaling factor. So for now, we're just going to do 1 meter chord length, but anyways, once you format them in this way, You could just go ahead and copy all this. Put on a new notebook. Text file. Paste that in. You'll notice that there's some zeros that are kind of off here. You don't have to tab these. I always thought you had to tab them over, but it's not really necessary, and it's smart enough in that regard. So you can just save this as this was SolidWorks, so I'm just going to save this as ANSYS, and make sure you save it as a text file. Save. This. I don't think I have to save this. I don't know. Actually, we'll keep this open now. Open up your workbench. I already have mine open because it takes a while to open. And then you'll double click on Fluent, and you'll have this little window here. Just do this as this critical 414. It's Airfoil. From there, you will. I like Design Modeler. I hope that didn't open it. Oh, okay. Design Modeler. You can usually right click on geometry and specifically choose Space Claim or Design Modeler. I prefer Design Modeler. It's a little bit janky, but it does. From here, what you'll do is you'll go to Tools, Connect, Create. I think it's still loading. First, let's create a sketch. Make sure all of these are here. I just got to see your concept. Oh, there it is. It's concept. No, my bad. It is points. So you want to click this point button here. And then what you'll do is you'll do from coordinates file. That should be already clicked off. You'll click this little button here. I believe it's here. ANSYS open. Once it's there, you'll click generate. And you should see here that it creates your airfoil, and it does create it in meters. So just keep that as a note. So again, you'll see all these points, and this process is going to be a little bit tedious and annoying, but I'll explain that in a second. So now what you need to do is essentially create like a surface for this, and make it kind of actually usable, like when you're going to make your geometry and flow domain. So to do that, you'll go to Concept, 3D Curve, and rather from Coordinates file, you can actually just click for point selection. And now comes the tedious part. And before I actually start clicking and getting tedious with this, one thing to note is you'll see the trailing edge here. It has like a weird gap here. You'll see why this is beneficial in a moment, but when you're trying to do like a zero thickness trailing edge, I actually prefer to actually kind of skip one of these coordinates. So I'll usually skip like maybe this one here and have the curve kind of come down smooth and create the zero thickness point at this region here. Just because you're going to mesh at some point, which is anticipated what you'll do in ANSYS, having this thickness here is going to cause a lot of issues with your meshing. So just a suggestion, you'll see the issues that it can create in the future. So what I like to do is to create that smooth edge there. I'll actually go to a really flat surface up here. Usually on the upper surface, maybe let's pick this point. Maybe these points here look pretty flat. So again, this is where the tedious part is. So you'll just basically want to click, and I usually just click and hold and kind of drag across these points. Be careful not to skip any points. You don't want to have to start over. Yeah, so bear with me for a moment while I try to click these. If I miss one, it's not the end of the world. If you're doing this for a project, it's probably recommended to go back. So this. Again, this is going to be kind of boring. You might want to skip through this part if you're watching the video. One thing to note is that now we're here. We're going to skip this edge point, or I'm going to, and you'll see that it's actually going to create a little bit of a bump here, but that's not going to be terrible if you're just kind of doing this for general research work. But yeah, you'll see that it creates, again, this zero thickness point here, which is very important for the future analysis in the meshing. Again, you can feel free to skip through at this point. I'm just going to go through and click all these. Unfortunately, this airfoil has a lot of coordinates, so this is where the tedious aspect comes into play. I skipped a point here by accident, so I'm going to ignore that for now. If I went to try to go back and click that, it would actually like make a weird glitch, and the curve would try to close itself, and it wouldn't let you. So depending on how patient you are or how important you think that point is, you can go ahead and skip it or go back and redo everything. So yeah, this 3D curve is really nice because it'll basically create like a smooth line. So you don't have any like weird discontinuities in your airfoil. Oh, I'll skip that one. Oh, this is such a process. Okay, cool. And you want to go to this last point here. So now what you'll do is click apply, and you don't want to connect these points. Just leave this open as a heads up. Do not click that last point. Click apply and generate. So now you'll have this curve that has been created for your airfoil. You need to actually make another curve now, 3D curve, point selection, specifically trying to connect the 2 points that you didn't connect previously, which we see curve 1 is there, so we need to connect these 2 points here and here. Apply, generate. And I do this just because it's a really flat region. If you try to do this with a trailing edge, rather than having like a smooth curve, you're gonna have a really sharp edge like here, and your mesh just gets really wonky. So have a smooth curve here, and then on your flat surface, create that flat region where you can connect them. And the reason you have to do that is because ANSYS is weird and it doesn't like to connect 3D curves if you can't have a full completed enclosed 3D curve. So for that reason, when you try to connect the points, it gives you an error. So that's why you create these 2 curves here. Now, say you're trying to create like a surface from these points. What you'd have to do is go to Concept, Surfaces from Edges, and you'll click the big curve, and you'll just Control and select that one as well. Click Apply and Generate. That will give you your surface for your airfoil. So that's, I guess, kind of like the general gist of it. From here, you can kind of do whatever you'd like. Again, trailing edge, I'll leave that up to the person obviously watching this video. I highly suggest this method as it's been a lot of trial and error to try to correct for this, and it's worked pretty well. Now, if you need a thickness that's a little bit different, just realize that your meshing might be a little bit challenging. So yeah, without any more blabber, I guess that's pretty much it for this video. If you have any questions or anything, you can leave a comment. I'll try to answer them. And then in the next video, I'm going to be showing you kind of how to create a proper domain for a mesh analysis, specifically for a structured mesh. And yeah, anyways, thank you for watching, and I'll catch you in the next video.